Hello friends, welcome to Mathematics Portal, and today we are going to discuss problems on synthetic division. In our earlier lecture we have already discussed what is the synthetic division. So you can find the video number 3 in the numerical analysis playlist of our channel and find the synthetic division, or you can go to the link I have described in the description of this video, so you can find it easily. So let's start our topic, the problems on synthetic division. I have chosen some great problems on the synthetic division. So you can see there is one of the problems. So you can see that there is a polynomial of 4th degree and a divisor which is 3x minus 2, but you can see that this divisor is not in the ideal form because the highest power of x have not the coefficient equals to 1. So first we putting this divisor into ideal form. So we take 3 out of 3x minus 2 and we get x minus 2 by 3. So for this synthetic division we write down the Hornor's scheme. So for this purpose we write down the coefficients of the polynomial here in the first row, and here this is minus 2 by 3, so we put it down opposite of minus 2 by 3, which is plus 2 by 3. Now again using the Hornor's scheme, on leaving the first place we get 1, on multiplying 2 by 3 to 1 we get 2 by 3 here, on adding 4 minus 4 to 2 by 3 we get minus 10 by 3, again multiplying this to minus 10 by 3 and write down here, on adding 6 to it now we get 34 by 9, and this process is going on. Now you can see that the divisor is of 1 degree and polynomial is of 4 degree, so quotient should be 3 degree. So first we write down the coefficient for this scheme. So we write down x to the power 3 and choosing the coefficient here. The first coefficient is 1, so this is 1. The next coefficient is minus 10 by 3, which is minus 10 by 3, x to the power 2. The next coefficient is 34 by 9, so write down here, and this is x, and this is our last term, so write down here, this should be constant, and you can see that there is a one term remaining, so this remaining term is our remainder, so we have write down here. Now you can see that we have already taken 3 out of this, so on dividing 3 to this quotient we get the final answer. So on dividing 3 we get minus 1, we get 1 by 3x to the power cube minus 10 by 9 x square plus 34 by 27x minus 40 by 81. This is our quotient and this is our remainder. Now we have another example. There is a polynomial of 5 degree and a divisor is of x square minus x plus 2. Divisor is of the power 2 and polynomial is of the power x to the power 5. So you can see that this divisor is in the ideal form because the coefficient of the highest power x is 1. Here is the highest power of x is 2 and the coefficient of x square is 1, so this is in the ideal form. Now we find the Hornor's scheme for this polynomial. So in the first row we write down the coefficient of this polynomial. So we have write 2 minus 3 4 minus 5 6 and minus 7. You can see that the second term of the divisor is minus x, so the coefficient is minus 1, so we write down here plus 1. The coefficient of the last term is 2, so we write down here minus 2. Now leaving the first place we write down 2, on multiplying 1 to 2 we put it here, again leaving the second place, on adding minus 3 to 2 we get minus 1, on again multiplying 1 to minus 1 we get minus 1, again multiplying minus 2 to 2 we get minus 4, on adding this we get minus 1. Now again multiplying 1 to minus 1 we get minus 1 here, again multiplying minus 2 to minus 1 we get plus 2 here, on adding this we get minus 4. Now again multiplying 1 to minus 4, we get minus 4 here, and again multiplying minus 2 to minus 1, we get plus 2. On adding this, we get 4. On again multiplying here, which is not necessary, I will tell you why. Now again multiplying minus 2 to this minus 4, we get 8. So you can see that the divisor is of second degree polynomial, and given dividend is of the power x to the power 5. So quotient should be 3 degree polynomial. So we write down the coefficient from here. So first coefficient is 2, second coefficient is minus 1, third coefficient is minus 1, and last term is minus 4, which is our constant. So you can see that there are two terms remaining. So these two terms are the coefficients of our remainder. So there are two terms, so there should be a 1 degree polynomial, which is 4x plus 1. So this is our final answer. Okay, now you can see that we have multiplied 1 to 2 and write down here, again this to this and write down here, again multiplying this to this and write down here, again multiplying this to this and write down here. But we don't multiply this 1 to 4 and write down here. Why? Because you can see that this is the divisor of 2 degree and polynomial is of 5 degree. So our quotient should be of 3 degree, and in 3 degree polynomial there should be maximum up to the 4 terms, and we have already find out 1, 2, 3 and 4 terms. So there is no need to find another term. So this is why we don't multiply this 1 to this 1 to 4 and write down here. Similarly, in the next term is we have write down only 1, 2, 3 and 4 terms. So this is why, and these things we have to keep in mind on writing down the honors scheme. So, and now we have another example which is of the 5 degree polynomial, but you can see that there is a divisor of second degree, but this is not in the ideal form. So first we put it into the ideal form. So we take 2 out of this, we get x square minus x by 2 plus 1 by 2. Now you can see that the highest power of x have the coefficient 1. So this is in the ideal form. Now we writing the honors scheme for this polynomial. So we write down the coefficient of the polynomial 2, minus 3, 4, minus 5, 6 and 2. So 2 minus 3, 4 minus 5, 6 and 2. The second term is minus 1 by 2, so we write down here plus 1 by 2. The third term is plus 1 by 2, so we write down here minus 1 by 2. Now again leaving the first place and write down here 2. On multiplying 1 by 2 to 2, we get plus 1. Again leaving the first place, on adding we get minus 2. Again multiplying 1 by 2 to minus 2, we get minus 1. Now again multiplying minus 1 by 2 to 2, we get minus 1. On adding we get plus 2. Now again multiplying this 1 by 2 to 2, we get plus 1. Again multiplying minus 1 by 2 to minus 1 by 2, we get plus 1. On adding we get minus 3. Now again multiplying 1 by 2 to this minus 3, we get minus 3 by 2. Again multiplying minus 1 by 2 to 2, we get minus 1. And on adding we get 7 by 2. Now you can see that this is the quotient of divisor of 2 degree and polynomial is of 5 degree. So quotient should be of 3 degree polynomial. and this should have only 4 terms, and we have already find 1 2 3 and 4 coefficients, so there is no need to find here, so we write down blank. Now again multiplying minus 1 by 2 to minus 3 by 2, we get 3 by 2, and on adding this and this we get 7 by 2, and quotient should be of 4 terms, so 1 2 3 and 4 terms we have already find out. And now we writing the quotient for this polynomial. So the coefficient of the first term is 2, the coefficient of the second term is minus 2, coefficient of the third term is plus 2, and last term is constant, which is minus 3, and we have already taken 2 out. So now we dividing this polynomial by 2, we get the final quotient. So on multiplying by 1 by 2 we get x cube minus x square plus x minus 3 by 2. This is our final quotient for this polynomial, and you can see that there are remaining 2 terms, so this should be a polynomial of 1 degree, and our remainder will be 7 by 2x plus 7 by 2. This is our final remainder. So that is it in this video. If you like our channel and if you like our video, so please subscribe our channel Mathematics Portal and like us on Facebook and Instagram as well. Thanks for watching.